节唱呢，一个改定定节个，啥不可以我和唱呢，我给俩就讲我。
我在里面啦。
看你的左边的输入讲，
是啦。
你网红我讲 A P P， 很多要变金红的，没人说。
什么是金红来的？
哦，金红啊！有个是
那里
讲卖变金红了。
Sorry， 各位晚安。真厉害，挺是。We wait for others, huh? Okay, meanwhile, please get ready with your notes. Just now your chemistry, how many of them? How many of you over there? 12. So which means that there's still 5 or 4 more students haven't come yet. Okay, we wait for the other 4 or 5, then we will start the class. Okay. Meanwhile, your what? Please get ready with your notes. Please get ready with your notes. Okay, the index I have stated at the top part there. Okay, I will copy and paste again in the chat. Okay, so please get ready. Sim and Jen, mute your mic. Is Christina there just now? And also Yini here already. So she's not here yet. How about Puna? Okay lah. With 49 only, we will start already. 3:49 we start. So next week, if let's say the MCO extend, okay, our class will still on, okay, every Friday. But since before that you have your class chemistry ends at 3:30, I will start my class at 3:45. Okay, 3:45. So you all can rest a while first while you enter my after that only you enter your class, my class. Okay, so I think I should start now already lah, Okay, wait a while. Okay, what we are going to learn today is specific latent heat. Okay, last lesson we learned about specific heat capacity. The heat capacity is actually the heat absorbed for the object to increase in temperature. Okay, but what if it increase in temperature until a certain temperature already? It want to change the state. Okay, from one state to another state. What is the heat they are going to absorb or release? This is what we are going to learn for today. Okay, can Okay, so as you know, wait a moment. Okay, as you know, okay, we have three states of matter, okay, or three phase of matter, okay, which is what? Three phase of matter, which is okay, correct. Solid. Use solid, liquid, and gas. Correct. So we have three phase of matter, okay, or three states of matter, okay. Solid. Okay. Okay. Today we are going to learn specific. Hey, mama. Hey, y'all, wait a while. Okay. Okay. So today we are going to learn, okay, specific latent heat. Okay, so what I have said told you just now, we have three states of matter, which is solid, okay, liquid, and gas. Okay, so there are process for the solid to change into liquid. Okay, what is it? Okay, wait. And liquid change to gas. Okay, then gas change back to liquid, liquid change back to gas. So what is the process? Okay, melting, correct. Okay, solid to liquid is melting. Okay, boiling, correct. Boiling or evaporation, okay, or evaporation. Okay, then no, not sublimation. Gas to liquid is what? Con, not cooling. Con, correct. Con, then, sorry, wait. Okay, this one I use, okay, con, then station. Okay, then one is liquid to solid, it will be freezing, correct? Okay, so during these four processes, okay, melting, boiling, condensation, and freezing, okay, they are actually, the metals are actually absorbing heat or releasing heat for the matter to change from one phase to another phase. Okay, if let's say you want to change from solid to liquid, as you know, solid, the arrangement inside the solid, the particles are orderly arranged. Okay, but for liquid, it will move freely a little bit already. So in your opinion, in melting, the heat is absorbed or released in order for the solid to change into liquid. The heat is absorbed or released. Correct? It is absorbed. Same goes to from liquid to gas. Okay, the boiling process. Okay, the boiling process, the heat also being absorbed. Okay, so here this part, okay, I will separate this into two parts. Okay, I will separate this into two parts. Okay, can two parts. Okay, so in this part, okay, this part is heat is absorbed. Okay, heat is absorbed. Whereas for gas, change to liquid, liquid change to solid, which is condensation and freezing, heat is what? Heat is correct. Heat is released. So heat is released. And the heat that is absorbed or released in these four processes, we will call it as latent heat. Okay, so in for melting and boiling, okay, latent heat is absorbed. for the matter to change from one phase, which is solid, to liquid, liquid to gas. If let's say the gas want to change back into liquid, liquid want to change back into solid, this it will be latent heat is released. Okay, latent heat is released. Okay, can Okay, then we have two types of latent heat. Okay, one is latent heat of fusion, one is latent heat of vaporization. Okay, so for latent heat of fusion, it will actually involve in the process of changing solid to liquid or liquid back to solid. Okay, so here in this part, okay, in the solid, okay, solid to liquid, okay, we will call this latent heat absorbed or released. The latent heat is what we call as latent heat of fusion. Okay, fusion, can clear? Okay, if let's say involving liquid, okay, to gas or gas to liquid, okay, we will call this latent heat, it will be, sorry, I don't have much space here, I write over here, latent, yes, correct, heat of vaporization. Okay, so what are we going to learn today is actually the heat absorbed or released to allow the matter to change from one phase to another phase. And the phase, we have three phases: solid, liquid, and gas. So from solid to liquid, okay, liquid to gas, the heat is absorbed, latent heat is absorbed. From gas to liquid, liquid to solid, the latent heat is released. And if let's say the latent heat that is involving solid to liquid or liquid back to gas, it will be latent heat of fusion. Then if let's say liquid to gas, gas to liquid, it will be latent heat of vaporization. Okay, clear about this? Okay, this is like a summarize of what we are going to learn today. So you write down this one, latent heat, it will be 4.3. So this whole thing will be your notes number 1. Okay, 4.3. This whole thing will be your notes number 1. Okay, don't worry. Yeah, please wait a while. Okay. Okay, I have sent in the, yes, copy of this, okay? I have sent this diagram in your WhatsApp group already. So what you need to do is you just leave a few blanks, okay? Maybe a few lines, 10 lines to draw this diagram, okay, into your notes, okay? Into your notes, okay, okay, so I end here already, I continue with another part already, okay? Okay, next. We will go back to the screen here. Okay, so now we will talk more about latent heat, okay, in theoretical already. Okay, so for latent heat, okay, is involving in change of phase, and we have 3 types of phase. So this is why I've told you just now: solid, liquid, and gas. Okay, so the substance can be either absorbed or release heat energy, okay, without a change in temperature if it is undergoing a change of phase. Okay, just later on, I want you to take a note over there in the diagram there. Please take note, okay? The process of melting, freezing, okay, melting, boiling, condensation, and freezing, all these process will happen at a certain temperature only, okay? The temperature will remain unchanged without a change in temperature. So which means that it will, okay, you can take note over there, okay? Take note over there is the temperature. Sorry, my handwriting very curly. Well, remain, okay, constant. Okay, although my handwriting is like a zombie, okay, but I'm not a zombie, yeah. Okay, I hope you understand what am I drawing writing here. Okay, you write below the diagram that, okay, the temperature will remain constant. Okay, can I? Clear? So I continue already, yeah. Okay, yes. Okay, so over here, these are the what law? Okay, the processor from solid change to liquid, it will be melting. Then liquid change to gas, it will be evaporation or boiling. Then gas to liquid, it will be condensation. Liquid to solid, it will be freezing. Please take note that in latent heat, it does not involve, yes, only the forwards. Okay, correct. Okay, together with the diagram just now, see with the diagram that I draw just now. Okay, that one is notes number 1. Okay, okay, so please take note that for gas, solid directly change into gas or gas change back to solid is not involved in latent heat. Okay, it's not involved in latent heat. Only solid to liquid, liquid to gas. It doesn't like jump one phases. Okay, which it does not involve in the latent heat. Okay, can Okay, so this is the latent heat. Okay, okay, latent heat. Okay, definition of latent heat. Okay, I want you to copy this down. Okay, as notes number 2. Okay, number 2, you write down latent heat of fusion. Then you write down this one. Okay, is the is the latent heat of fusion. Okay, you write this the one that I will highlight later is the, okay, latent heat of fusion is the heat absorbed when a solid melt. Okay, melts. Okay, when you know solid, when you talk about solid melts, which means that it is changing from solid to liquid, and it will happen at a constant temperature. Constant temperature. So this constant temperature, if let's say is a melting, we will call that constant temperature is melting point. So for example, an ice will melt at 0 degrees Celsius. Okay, ice is an example of water. Water, there is ice, then water, then gas. Okay, so ice, it will only melt at melting point, which is 0 degrees Celsius. Okay, can So then, why is it the temperature will remain constant? Because the heat energy used is not to increase in temperature, but is used to break the bond between the particles, so that the solid, which is in an orderly arranged manner, is able to change into liquid. Okay, we need to break the bond. Okay, so the heat that is absorbed, which is the latent heat, is absorbed to use to break up the bond. Okay, to break up the bond. That's why the temperature will remain constant. Okay, so I want you to write down this and this also. Okay, so this one is number 2, and this one it will be number 3. Okay, number 3. Okay, so for a liquid to solidify at freezing point, okay, which is the process of freezing, latent heat of fusion is removed from it. So you can see, for melting, latent heat of fusion is absorbed. Then for freezing, latent heat of fusion is released. Okay, but both of these processes will happen at a constant temperature, which is 0 degrees Celsius. Okay, which means that melting point and freezing point, actually both also is the same temperature, which is 0 degrees Celsius for water lah. Okay, and why is it the temperature will remain constant? Because the heat absorbed is used to break the bond. Okay, to break the bond. Okay, the heat that is absorbed to increase in temperature, what is it? The heat absorbed to increase in temperature. What is the heat we call? Hello. Correct. Specific heat, not heat energy. Specific heat capacity. Okay, specific heat capacity. So you can see the difference already. Okay, so for specific heat capacity is actually the heat absorbed for the object to increase in temperature. And you reach a certain temperature already, is ready for it to change from one phase to another phase. And you see the temperature will remain constant. And the heat that is absorbed for the object to change from one phase to another phase, we will call it as latent heat. Okay, latent heat. So you must make sure you are on the right track. Yeah, to increase temperature is heat capacity. To the heat for the object to change from one phase to another phase, we will call it as latent heat. Okay, can clear? Finish already? The notes. Okay, have you done the notes? Have you done the notes? Okay, then I continue already. Okay, good. Okay, so this one. Okay, so this is it all. Okay, the solid. Okay, you see, initially is arranged in an orderly manner. Then you want to change it into liquid in the process of melting. So this one, latent heat of fusion is absorbed or released. Is absorbed or released? The latent heat is for solid changing into liquid. Absorb, correct. Then from liquid change back to solid, it will be latent heat of fusion is released. So in short, which is involving solid, liquid to solid, it will be latent heat of fusion. Fusion. Okay, good. Okay, now we will talk about latent heat of vaporization. So this is your notes number 4. Okay, so latent heat of vaporization is the heat, okay, heat require, okay, the heat absorbed, okay, for a liquid changes into vapor at constant temperature. And the constant temperature usually we will call as boiling point. Okay, same. Why is it, okay, the temperature will remain constant? Okay, because the heat, okay, this one is note number 5. Okay, this one is note number 5. Okay, the heat absorbed is used to completely break the bond between the particles. As you know, liquid, when you want to change it into gas, it must be moving more freely already. So which means that the bond must be break more already. So the heat energy, the latent heat that is absorbed is actually used to break the bond and also to do work against the atmospheric pressure when the gas vapor expand into the atmosphere. As you know, if let's say it's a liquid, okay, it's a liquid, okay, it slowly change into gas already. The gas particle wants to escape out from the liquid, but the atmospheric pressure is too strong already, which is higher than the gas pressure here. Okay, so what you need to do is you need to supply it more heat energy. Okay, why? Because if you supply more heat energy to it, it actually will gain more kinetic energy for these gas particles to escape out from the atmosphere. That's why the heat energy is absorbed for that particular purpose. That's why the temperature won't increase. Okay, so this is the two reasons why in boiling, okay, in latent heat of vaporization, the temperature will remain constant because the heat is used to break the bond and also to do work against the atmospheric pressure. Okay, clear? Clear? Hello, clear or not? The one with the heat. Oh no, my God. Very good. Okay. Okay, so now we will look at next slide already, no? Okay, so this is gas to liquid, okay? Sorry, liquid to gas, latent heat of vaporization is? Okay, liquid to gas, latent heat of vaporization is? Is? Is what? No one want to heal me. Okay lah, I start myself lah. Okay, your head, Jen. Liquid to gas, liquid to gas. Liquid to gas, latent heat of vaporization is absorb. Absorb. Okay, from gas back to liquid, the latent heat of vaporization is released. And both of these process will happen at a constant temperature. Okay, at a constant temperature, which is a particular temperature. Okay, why? Because the heat is absorbed to do what? Yes, break the bond molecules and also to do work against the atmospheric pressure. Okay? Can I break up? Break up with who? Okay? So this is a summary lah. Okay, summary of what we have learned just now. Okay, so for melting and boiling, it will be latent heat is absorbed. Okay, then for condensation and freezing, latent heat is released. Okay, then one more thing. Again, so for liquid to gas, what is the latent heat involved? Liquid to gas. Wait, you let me do this first. Later I will go back. Okay, later I will go back. Okay, so for liquid to gas, what is the latent heat involved? Correct, latent heat or not evaporation, vaporization. See ma? Okay, see ma? Okay, then from solid to liquid, liquid to gas, it will be latent heat of fusion. Correct, latent heat of fusion. Okay, so this one, it will be notes number 6. Okay, the characteristic for all these 4 process, it will be, okay, undergo a change of phase, okay, at a particular temperature. And the heat is transferred, either is absorbed or released. And during that process, the temperature will remain constant. The temperature will remain constant. Okay, so I go back to notes number 4 and number 5. Okay, so this is notes number 4 and number 5. I will only be here for 2 minutes, so please faster. Okay, while you are copying, I go and see whether got any news for our MCO or not. I cannot. Really dilanjut already Sure. Oh my god. Until 28th of April. Okay, so our class is still continue until every Friday 3:45 I will see you Okay, so sad. Done. Okay, not happy leh. Actually, I don't like it leh. Done already Done. 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 Hello. Don't want to hear me. One more minute I want to move on already Okay, so Uma said done already so everyone should be done already My friend just told me that sekolah bermula apabila keadaan sempuh sepenuhnya. So y'all get ready to stay at home long time Then how? Then y'all no need to have PPT already Okay? So this one is notes number 6 Notes number 6 No need to draw this diagram. I just want you to copy down this wording on it. Okay? Okay? No PPT, okay, but I want school. Apa lah ini, Alia? I also don't like online class. Never mind. It's okay. We have to go through it. Okay? Can? Done? Done ah? Can ah? So I continue already ah? Okay, so for latent heat, okay, we need to learn about two types of graph. One graph, it will be the heating curve. One is the cooling curve. Okay, so you all will, huh? Hey, by the way, if let's say your parents, anyone can get any mask, please get ready the mask, okay? Because the school reopen also, we still need to wear on the mask. Okay? Can if possible lah. Okay. So now I will share you with the whiteboard. Okay. So you see here. Okay, you see here. Now we will talk about this one is notes number 7 already. 7 it will be heating curve. Okay, heating curve. So we have like this. Okay, this is the x-axis and y-axis. Please draw using ruler. I don't have ruler, so that's why I cannot draw. Okay, so this is the state. Okay, or we call it as phase lah. Okay, then this is the temperature. Temperature in degree Celsius. Okay, so what happened is, okay, the temperature will getting increase. Okay, increase and increase. Okay, increase and increase. Okay, for the temperature to increase, what is the heat that is absorbed? For the object to increase in temperature, what is the heat that is absorbed? Hello. Hello. And this one, no one wants to answer me. Correct. Heat capacity. Okay. So here around, I will write heat capacity. Okay, heat capacity. And this one, it will okay, low, solid, low. Okay, this will be in solid state. Okay, solid state. Okay, next, when you reach that particular temperature, which is here, it will be the melting point lah. So I write here melting point. Okay, so it will start to melt. Okay, it will start to melt. So the temperature will remain constant. Okay, kenapa dia punya temperature will remain constant? Agak less than 1 minute only. You go out from this meeting already, you come back again. Okay, go out from this meeting and come back again. Okay. Every 40 minutes, I will need to end the meeting already. Okay. Go back. Come back again.